In this demo, we will see how we can configure the 1SI CANopen. This module enables communication between an ET200S system and any industrial device on a CANopen network, for example, a robot, drive, sensor, inverter, or measuring device. In this example, we're using a drive as slave on the CANopen side. I have downloaded the configuration tool from ET200can.com and installed it on my computer. First, I need to set up some general network settings, such as deciding whether I should use predefined connection linking or unlimited object linking. Predefined connection linking means that I can only change the data mapping in the master. But in this case, I want to use unlimited object linking, which means that I can change the mapping on all my connected nodes, both on the master side and on the slave side. I also want to change the baud rate. I set this to 500. I have now configured the general network settings and can move on to set up the connected nodes. In this case, I want to add two nodes, the 1SI CANopen module and my drive. I add two new nodes by simply right-clicking and selecting Add New Node. Next, I want to specify how my two nodes should behave on the network. This is done with an EDS file, a configuration file which determines the behavior of each node. The EDS file is provided by the device manufacturer. Node 1 is our master, so I right-click on it and select Load EDS File. I then get to my EDS repository where I can choose the 1SI CANopen module. I now move on to configuring my slave node, but first I want to change the node ID from 2 to 8 since I have installed my slave drive on node 8. I right-click and select Change Node ID and change the number to 8. I then want to load my EDS file for my drive. In this example, an EDS file is not yet present in my EDS repository. I therefore need to select another file and browse my way to the correct EDS file. With the EDS files loaded, I now need to specify that my first node is my master. By doing this, I get a number of master settings. I select the settings that I want to apply to my master. Download Concise DCF means that the master should download the configuration and configure the network when you turn it on. Download NMT Startup Config determines that I want to enable the choices which I can see here to the right. We get to these in a moment. Download Slave Assignment means that we download the configuration to the slave devices. We'll set up the slave settings later in this presentation. The NMT Startup Configuration, which we just enabled in the master settings, specifies how the gateway should act at startup. I tick the box saying that our 1SI CANopen module is the NMT master. This means that the module should manage all NMT services, like, for example, monitoring the network. The next option specifies that the master should start up all nodes individually or the entire network. By ticking this box, I specify that I want to start up all nodes at once. Finally, I also indicate that the application will decide when to switch to operational mode. This means that the ET200S system or top-level PLC now decides the operation mode. I then move on to the settings for the slave device. Just like on the master side, I need to specify how the device should act at startup. I select the option Node is NMT slave and available. I also want the master to boot up and configure this slave when it is detected or redetected. Finally, I want this node to be mandatory on the network. This means that the network will not start up until the node is present. I am now finished with my system settings and can move on to configure what data I want to transfer through the 1SI CANopen module. In other words, what do I want to send from the master to the slave and vice versa? I start with my master node. By clicking the Table tab, I can see the bytes that are being transmitted from the 1SI CANopen module and the bytes that are received by my slave device. Since my slave device was on node 8, I first need to collapse node 1, which I do by right-clicking and selecting Collapse Node. I also need to collapse the 8-bit objects to get to the correct mapping. I select the objects that I want to map together. In this case, we map generic word transmit object 1 to operation com, transmit object 2 to speed com, and so on. We also want to get some status information from the slave side. I therefore move on to my slave node, node 8. Here I can see node 8 on the x-axis instead. Since I collapsed node 1 previously, I expand this node and select the objects I want to map. We are now finished with the configuration, and I can test it for any errors by choosing Data Linking and Generate PDO Linking. This creates a linking table with all objects that are sent through the 1SI CANopen module. If there are any errors, I will receive a notification about this. By choosing Write DCF Files and Documentation, I can save this on my hard drive. Finally, I want to send my configuration to the CANopen network. I connect to the network via USB to CAN interface. I specify which CAN interface I want to use by selecting Connection and CAN interface configuration. Here, I'm using the CANFox interface. I load the driver for the CANFox interface from my hard drive and select 500 as baud rate. By clicking the Connect button, the software now looks for HMS masters on the network. When this arrow turns blue, I can click it to send the configuration to the network. I click Yes to send the configuration. I also want to regenerate the linking configuration and the DCF files, which I should do if I've made any changes since the last time. The software now creates new linking tables. I am now asked whether I want to store this in the connected nodes. By clicking Yes, the parameters will be stored in all connected devices that support storing of parameters. I can now disconnect from the network, since all parameters have been saved on the network devices.